In previous sessions, we looked at how we survey an archaeological site using tapes and measures. But there's another technique open to diving archaeologists to use. And that is by using the humble camera, an old version which I show here, and now sophisticated software. And this creates what we call a photomosaic. My name is Haigh. I'm the project director of an operation called Wreck Hunters, which aims to teach the skills and techniques of diving archaeology based on the tiny Caribbean of Utila, focused on an 18th century wreck we call the Oliver, lying in 18 meters of crystal clear water, which is normally at a sea temperature of 30 degrees. And I've been running a series of sessions which have explained the ways that diving archaeologists deal with some of the challenges they face. And today we're going to look at photomosaics. Remembering always, some of the things we talk about are complex or require risk assessment, and you need to carry them out only with proper training. There are some problems that diving archaeologists face which our colleagues on land do not have to deal with. And for me, the three biggest are these. First is the lack of time. Obviously, that can be due to the depth of the site, giving you shorter bottom times, but equally can be due with the cold. In 2014, the Parks Department of Canada rediscovered the ship the Erebus, a wreck from the doomed Franklin operation. The wreck was only at 11 meters. The time the archaeologists spend on the site, however, is determined by the freezing cold Arctic water. And in fact, the wreck is only available to dive 3 months a year. The second issue we have is to do with visibility. The sediments that preserve many ancient wrecks make it difficult to see them. The best example is, of course, the Mary Rose, where the divers had to work in very limited visibility indeed to recover the wreck and her remains. And the third problem is the inability for us to be able to show our sites to most people. Most people cannot dive, and even if they could, many of the sites are not blessed with great visibility. And the answer to these problems can be a photomosaic. What that is a series of overlapping virtual photographs which are put together to give you a picture. Traditionally, archaeologists use it in 4 ways. First of all, to give an overview of the site. It may in fact be the only way you can see a site at all. The second application is as a display item, especially for fundraising. It's easier to get people to part with money for projects if they can see the actual wreck that their money is going towards the preservation of. The third reason is recording. Photography is a complementary method to the other forms of recording we use, mainly drawing. And the third reason that photomosaics are used are in rescue situations where a wreck could be destroyed. In the case of the Erebus, found in 2014, when the Parks Department returned in 2018, they discovered that the whole of the upper deck layer had been ripped up by winter storms and ice. In these situations, it's important to get that photographic record before your wreck becomes more destroyed than it is. So how do we go about creating these things? Well, there's 2 main ways. The first method is very simple. You can simply fly over the site, taking overlapping vertical photographs, which you then join together. This, however, is quite inaccurate. By the very nature of a diver just hovering, the depth is likely to be non-consistent, and you have no reference points. So in order to get the discipline of those vertical photographs and put them together to make a photograph, you need to come up with some form of physical structure to help you. And this is normally done by the creation of a set of rails and a photo tower. Now, it's important with this that you don't go overboard, because at the end of the day, you're going to have to move this thing around underwater, and that can be difficult. The photo tower allows the camera, and often I used to use my Nikonus 5 for this, to be held steady and therefore able to take a very accurate vertical photograph. Sometimes, because the site was different, we used to use it in elevation as well. So that was the power of the tower. The tower also had the grid at the bottom, normally 1 metre square, and this linked to the divers who were also doing drawings at 1 metre square, so you can compare the two. And finally, because the camera was held by the tower and therefore held still, it allowed you to change the settings to get a better depth of field. So all these things make the photo tower and rails the preferred method of getting an accurate photomosaic. Many, in fact, would argue that, again, the pictures is the easy bit. Putting them together is the hard one. What you want to avoid is ending up with a picture which looks like a bunch of photographs just stuck together, because that looks pretty poor. In the old days, before the digital era, the way this was done was by getting this 40% overlap on each shot and then peeling away the edges of the photographs to avoid this sharp separation. To take that step one further, we used to sometimes soak the photographs in water, peeling back the photos until just the emulsion level was left, and then literally sticking these together on a board. Nowadays, we can use more advanced technology. If using Photoshop, the photo merge application will do the job for you. Although it's important to get that 40% overlap and to get the pictures lined up in manual, not in automatic. If you have a big site to cover, you need to take rows of photographs and merge them together. But these results can be spectacular. So, all of the examples of the photomosaic being used to great value. Let's use 3 examples. Off the coast of northern Sicily is the island of Panarea, and off Panarea lies a wreck called the Relito Alberti, or Alberti's wreck. She lies in 40 metres of water. She dates to the 1st century AD, is a well-preserved but jumbled wreck site. Back in 1987, the Oxford University Mare team went there with the idea of obtaining a photomosaic so that we could decide on which parts of the wreck the focus of attention should be in the future. A grid of ropes was laid out at 40 metres, and one diver, that would be me, hovered at 30 metres and took the photographs. The result was good enough for publication. A different example, it comes from the wreck of Isdella Calenti on the southeastern shores of Sicily. The beaches, in fact, where the Americans landed in the Second World War. Here lies a Roman marble wreck from the 3rd century AD. The problem here was that the marble columns, after centuries underwater, had become indiscernible from the other rocks around the area. So, when we did produce a photomosaic, we actually had to use Tipex to show the columns as opposed to the rocks. However, using a photomosaic in panoramic mode produced an image of the wreck site in its true glory. And the 3rd example is from Studland Bay, the wreck of a Spanish trader from about 1500 AD. As many of you know, the visibility in Lyme Bay is not great, often normally about 2 metres. And getting a photomosaic of the starboard side of the vessel, measuring 22.5 metres by 3.5 metres, was never going to be easy. However, with the help of a photo tower constructed by Andrew Bowley, myself, and students from the then Bournemouth Technology College, this was done. I still have the camera. Over 3 weekends, the site was cleared. Using the photo tower, I took the pictures, which were then put together to give us the image of the wreck that you would never see whilst diving, because because the visibility was too poor. Photomosaics really help the diving archaeologists. Next time, we're going to look at the processes involved in the excavation of an archaeological site. Until then, I wish you all safe and enjoyable diving.